couple important things up on the board. On Tuesday, we do not have any lecture. We're just going to make it a lab day. And so you can start the lab test as early as 5. Just make sure you don't show up any later than 6. So anywhere between 5 and 6 you can show up and start the lab practical. When you come to the lab practical, you'll be turning in your comprehensive, which I have revised. And don't look at it because we're all staying in a good mood.
Oh no.
Staying in it for being happy.
What is that?
The truth.
Because it's 25 more questions.
Oh,
You said 10, and then 15, and 20, and then
I
25.
know I got on the way
Oh my God.
You can take that back, you know.
So it's equivalent to a test. Do not complain. You can use your book. You can use the computer. It should be like a 100%. No, there's no complaining. That will never happen again in my teaching career. So take advantage. So typed, stapled. Don't say, hey, my printer broke. Can I email it to you tonight? No. So you have to turn it in so I can read it. I'm not grading Sierra. You want the laser pointer in your eyeball? So please let me grade it.
No way.
No way, what?
Oh, Lord.
All right, now Rick asked a great question. He said that the mastering assignments were still Sierra. I shouldn't even say it. So do not do 13 and 14 on mastering, and if you already did, just pat yourself on the back.
Extra credit?
No.
That's extra
She
credit?
doesn't have to answer 5 of the extra questions.
I don't have to answer the last question.
No, that's the best one. All right, so today, our last lecture, we are going to cover something that we have already talked a little bit about in lab, and that is the spinal cord. And some of the parts of lecture today should be reviewed, but we get to go in some really cool detail. We're going to talk about some diseases, and we're going to talk about, a person that I really look up to, and you will learn more about him as you do your take-home exam, and we'll move on from that. Okay, so let's start with the spinal cord. As I tried to explain in the lab, that I think the spinal cord is best described as an information highway. Information is traveling up towards the brain and away from the brain. And we're going to say that the spinal cord is the other component of the central nervous system. Remember how we had the major divisions. Central nervous system is the brain, and spinal cord, peripheral nervous system are all the nerves. So when we think of the spinal cord, it obviously has to be able to transport an electrical signal. So conduction is a big word, conduction. We'll be talking about transduction today in lab. Some of you already heard about that. Locomotion, which means that generally the response is to some type of, not always, but sometimes some type of effector that allows us to move and have a reflex. A lot of reflexes are involving movement. And then when we think of spinal cord assessment, usually it is done by reflex testing. So whether or not the pathway is intact is whether or not you give a normal or healthy response. And the last 10 or 15 minutes of class today, we get to talk about reflexes in much greater detail than we did in lab. Lab, we just talked about it for 2 minutes and you whack someone's knee. So today we get to talk a little bit about it in more detail. Now, just like we saw in lab, the spinal cord is about the same thickness as someone's finger, and there's lots of nerves that come off of it. And of course, you would never have to know the number 31. But as each branch comes off the nerve, it continues to branch and branch and branch. And so one of the terms that you're probably going to be seeing eventually is the word plexus, and we saw that in lab. Plexus means a overlapping nerve network. Think of it kind of like a mesh of nerves kind of overlapping. That's usually what you describe as a plexus. So in lab, you learned that there's a lumbar, there's a brachial plexus, there's other plexi, and you just have to know the general locations for lab, not so much in lecture. When you look at the spinal cord, it does change shape though. This is kind of weird. As it gets down towards our butt, it starts to kind of get bigger and wider. In fact, look what it's called. It's called the cauda equinae, which means horse's tail. And take a look. Here you can see a tube with the spinal nerves branching off of it. And then it starts to getting wider. And then it starts doing something that kind of looks like a tail. So this is one of the reasons why we have larger vertebrae towards our butt. Remember the moose? It's not a giraffe. So the moose is larger, it's able to house a wider cord. And some of these nerve endings that come off our cauda equinae go all the way down to our feet. So they're very, very impressive. Some of us, as we get older, will have, you know, maybe something called sciatica. That's something that a lot of older people have. You know, they feel like their leg is tingling. It has a lot to do sometimes with a pinched nerve in the lumbar region. You'll hear more about that, I'm sure, in your clinicals, but that's something that kind of represents a very long nerve that goes all the way to your foot. Like we talked about in lab, we said that when we did the dissection of the spinal cord and the brain, that there were 3 membranes that surround them. So you should be good with the meninges. We know that the outermost is one tough mother, right? The dura. We said the arachnoid was a fluid-filled space that had these little dangling things that appear like spider webs. And we called the pia the saran wrap of the spinal cord, or was the shiny surface of the brain. You all have great pictures of these, so you know, this is nice that we did a lab in advance to the lecture, because you can visualize that. So take a look at this. This kind of summarizes everything that we've seen in lab, and it's also going to talk about some structures that are related to the actual vertebrae. And you can see that this is a cervical vertebrae because it has these little holes behind the transverse process. It also has this bifid process. Those are the 2 characteristics that we talked about that make cervical cervical. But if you look, you can see that the spinal cord has, look, the dark gray butterfly wings. It has white matter. It has a thick, tough mother around it. It has this blue fluid that have little spider webs dangling on it. That's the arachnoid, 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 arachnoid. And then we have the pia, which is very hard to see, but it's the thin lining or wrapping around the spinal cord. So what I think we should do is I think we should draw that and get ready for something that I think will make sense once we get into the world of reflexes. So go ahead and draw the cross-section of the spinal cord, like we did in lab. We're going to say cross-section of spinal cord, butterfly wings, which we could say gray matter. So you might want to shade this in and say gray matter. We said thick, outer, tough mother is the dura. So dura. We said dangling things, liquid. I guess we could put little waves of liquid, dangling things. So this is arachnoid. And then we said that there's a little thin wrapping around spinal cord that we said was the pia. Okay, so that should be a complete review from lab. But one of the things that we're going to talk about today is that inside the white matter, Remember why white matters white. Remember we said white matters white because it has myelin, lots of axons. There are tracks that go up towards the brain, and there are tracks that go down towards the effector. So so a track is an axon. And we have ascending, which means going up towards the brain, and we have descending tracks. We can't really see them, but we know that they exist. We also have nerves that we said branch off in groups of 31, called spinal nerves. So this is kind of what a nerve looks like. It connects to the top and bottom, but we don't say top and bottom, we say the dorsal and the ventral. So there's a dorsal and ventral on the other side. But what's weird about the dorsal nerve is that it bulges out. Like this. And the ventral doesn't. Over here we have the same thing. Gigantic bulge and the ventral. So this is what a spinal nerve looks like. It has a dorsal and a ventral. Sometimes they refer to them as roots. But inside the dorsal, and the reason why it has this big swelling is that we have cell bodies. You guys remember what those are? Structures that dendrites attach to. So those are cell bodies with nuclei present. And those take up a lot of space. So we call this swelling a ganglion. So a ganglion is a swelling in a nerve. And the reason why we have a swelling is because we have all these cell bodies. Now what we have drawn really is a much more detailed kind of version of that very first diagram that we did a week and a half ago, when we said stimulus / receptor. And look, we said information travels toward the spinal cord through sensory neurons, and we said that this is an afferent direction. So now what we can say about our drawing and the model that you're thinking about maybe, that you have a picture of on your phone from lab, is that in this dorsal root, where we have dorsal root cell bodies, these are all sensory. So the dorsal is taking information, look, towards the spinal cord. And the ventral is motor, taking it in an efferent direction towards the effector. One of our big topics for today is going to be ALS. Tough one to talk about. And for ALS, the destruction that takes place in this pathway begins right here. The ventral roots start to get destroyed. So the brain is receiving some stimulus, but there's no response. So the muscles stop working, stop responding. Eventually a person stops breathing, needs a ventilator, stops talking, and then the heart eventually stops pumping. That's a tough one, ALS. But when you think about the pathway, it kind of makes sense. So we've amped up our drawing from day one of the nervous system to include a lot of terms that we are gonna talk about today. And we're gonna look at the details of this white and gray matter in the next few slides. So when we think of this drawing now, we can now appreciate, look at this, here is a dorsal root ganglion, yay. Here is the ventral root. They merge to form one spinal nerve. Remember we said that there's 31 pairs, so this is one pair. Over here we would have a dorsal root and a ventral root. But what's hard to see from this particular slide is that the way that the spinal cord is situated inside the vertebrae is that there's also some protection. So let's take a look at this. So the spinal cord has that gigantic opening where we have the spinal cord existing, and yet there is some space. And look what we have in this space above, stay with me, above the dura. Oh, guess what we call that? Epidura. It's all coming together. I love anatomy. So on top of the dura, like the epidermis, we have the epidural space. And in most cases, look, it's just fat. And you say, oh, but I've got to lose fat. I hate fat. I'm trying to avoid. No, we need fat for cushioning. So when we think of the epidural space, some of you immediately think, oh, childhood. You know, I needed that epidural to get through that. Or for me, for a guy, I had a herniated disc. And so I had to get a shot in my lumbar vertebrae in my epidural space. Yeah, John.
Just had a question. I remember you were talking about like the fat that we need when we talked about our kidneys. You saying that our
Oh,
kidneys
yeah.
are suspended in fat, right?
100%.
So if somebody went on this extreme diet
No.
or something where they wanted to, would our body take fat from those areas?
I don't think so.
Okay.
I don't think so. I think it would take fat from
Just everywhere else. Huh?
everywhere else. I don't think. I think that would result in like, maybe in extreme starvation. But if you were like keto, if you're saying I'm not going to, you know, eat any carbs and rely on my body to use carbs from fat, you lose fat like that, I think there's a limit. But I think maybe extreme starvation, maybe, Josh. Yeah, Michael.
So I heard that, so with an epidural before giving birth,
Yeah.
that there, so it's not as healthy necessarily for the baby, because apparently you lose a certain level of control with it, because you can't feel the contractions and everything as well. I don't know for experience.
Well,
I don't wanna
I don't
start.
think the anesthesia crosses into the placenta, so I don't think there's any danger with the drug.
Well,
But
not
in
to the
terms
baby
of-
itself, but like for the mother giving birth, can't necessarily feel as much.
Well, that's 100% true, but I
might.
think most women are saying that that's okay with me.
Yeah, well, they can't,
Yeah.
because they can't feel as much, they might end up in labor longer because.
Yeah.
They monitor it.
They might-
They
might-
turn it down right when you're about to do it.
They might also, you know, blow out a few hemorrhoids because they didn't feel anything, but, you know, I don't know, I think most women are willing for
When your
epidural.
body is having a
Yeah.
contraction.
Yeah, they monitor all your.
Yeah, you have still stickies on your
I think most women are okay with that.
Yeah.
So I want to show you a video of a woman getting an epidural. Hopefully it works.
Searching for a beach vacation? Find it at Verbo. They search millions of homes to find your perfect beach house.
Planning for an epidural, yes. I want to enjoy the last few hours. Enjoy her coming out. You know, the epidural just, for a lot of women, it helps relax them. It allows their uterus to do the work without the woman fighting against the pain. So especially at the end, when mom's exhausted, I think the epidural just helps them, give them some relief.
That needle was for you, Am. this is that they inserted that needle into the epidural space amazingly without an x-ray, you know? They know kind of by feel how far they should go, you know? And if they go too far, they're going into the spinal cord. Holy cow.
Does it just have to be anywhere then in that,
Anywhere
that
in,
the epidural?
anywhere in the fat, yeah.
No, if they went into the spinal cord,
That would be a disaster.
yeah,
That's a dumb question.
like, how did they learn that?
Ouch.
I think they probably practice on
Yeah,
like
I just felt.
plastic
That makes sense.
models.
Yeah, like
They
there's
have
something
some type of feel that simulates that.
They also have like a doctor
But
like there.
maybe the first few
An
times they do
anesthesiologist.
do it with
Yeah,
X-ray.
yeah. He's got a video of one on the Blackboard website.
I didn't see this.
Look at the power of the epidural, and now you're just all smiley and glowing.
And now I can actually tell patients how it feels like.
Okay, we're not gonna watch the entire movie. But anyway, the purpose of that is to get the woman's lower half completely numb. Most women will say that they don't feel their legs. Some of them will say, I don't feel my feet or toes. And so they do a good job of providing an anesthetic block to nerves that do a lot of overlapping. So they intentionally are going to numb several nerves in that area. It's kind of like when you get, you know, teeth work done and they're trying to numb your gum, but unfortunately the nerves to your tongue are so close that sometimes your tongue goes numb as well, you know? So there's overlap, there's plexi, right? And so that's one of the side effects. Now take a look at the top part of the vertebrae. If there is during development a deformation of this top part of the vertebrae, then the spinal cord has no boundaries and the dura has no boundaries, and it can result in spina bifida. Look at that. So this is all dura, this is all fluid that's being filled up, and this means that there was no kind of barrier or boundary for that particular
Can
area.
that be reversed?
No. I mean, I think now with maybe prenatal diagnosis, maybe some work can be done while the fetus is still inside of you. But
But that will always be there?
this baby's not gonna make it.
Oh, okay.
One of the things that was back in the day that was associated with spina bifida was folic acid. And I'm old enough to tell you that for my first kid, there was no such thing as prenatal vitamins. My wife was told, and they were serious, to eat something green every day. I mean, that's work. And for some people, that's expensive. You know, think about it. I mean, buying something green. So, you know, of course we tried. And by the time my wife was pregnant with our second kid, they had prenatal pills, which was prescription only. And now you can go to Walmart and get prenatal pills, you know, in the aisle. I've heard sometimes, I've heard sometimes that guys even take prenatal pills to get some of the benefits of certain aspects of the vitamins. But folic acid, we know, is one of the culprits that if in low quantities could lead to something like spina bifida. So if you're thinking about getting pregnant, you know, this is a dad moment. I would say start taking prenatal pills before you start thinking about getting pregnant. Get all of those folic acid and other things in your system before you get pregnant, because it's really important during that first trimester. Okay, so this was the diagram that was in lab, and I think this was the diagram that you took a picture of, right? And you might see this diagram on the lab practical on Tuesday. So let's take a look. We have the thick mother, right? Tough mother, dura. We have the webby arachnoid, and we have the pia. And then we have, here we go, the gray matter, the white matter, and we have the spinal nerves, which consist of a dorsal root and a dorsal root ganglion and a ventral root. And on the test, I think you'll see on the revised test that you may have to redraw what we drew on the board and kind of explain the pathway that we've been talking about. Now here is something that does not look realistically, but they show you some different colors to identify that within the white matter there are different tracks. And look, there are tracks that are ascending and descending, and then look at this one. Contralateral. Contralateral and ipsilateral. Now those are big terms. If you are going into any type of nursing field, you'll need to know those terms. I guarantee it, NCLEX worthy. Because many times in terms of diagnosis, we will do simple reflex tests that identify whether or not a track that is maybe potentially damaged is contra or ipsilateral. So let's talk about contralateral, right? This says that from the source, the stimulus, and as it's traveling up towards the brain, that it crosses over, ready, from the opposite side, and the destination is the opposite side of the brain. So think of the brain as two halves, two cerebral hemispheres. If I am touching with my right hand the stove that's on fire, then it's going to go up my spinal cord and, ready, cross over, contralateral, and my left side of my brain will sense it. So the left side of my brain senses and controls the right side of my body. How do you explain that? Because it is contralateral. And the process of crossing over, that we have to use some crazy word for that, means that it undergoes decussation. Big one. So nerves typically undergo decussation. That's a new term for most of you. That simply helps you describe why your aunt who has a stroke on the right side of the brain can't move the left side of her face, because information has undergone decussation. It was a contralateral nerve. There's a few cases where the nerve does not cross over. And we say that those nerves are ipsilateral, which mean they stay on the same side. So most paramedics, for example, will be trained to learn reflex tests, especially things dealing with eyes and responses, and whether it's an ipsilateral or contralateral reflex. Paramedic class that I teach at Cincinnati State, we go into a pretty big deal about trying to learn that and think about ways to learn that. For this class, I just want you to know that we have tracks. Tracks that go up and tracks that go down. Tracks that go up mainly cross over and undergo decussation. So here's an example. Here is some source coming from a receptor. This is what we drew on the board, just this one right down here. Notice that once it goes from the dorsal root ganglion to the dorsal root, it's traveling. Oh, look, it's crossing over. Decussation. It's going, its final destination is usually somewhere up here in gray matter, what we would call the cerebral cortex. So in most pathways, what we're going to say, and you don't of course need to know any of this stuff, is that it usually takes 3 neurons to get to the final destination. The first neuron, which is the sensory neuron. The second neuron is where we see decussation. And the third neuron is usually in the cerebral cortex. So most ascending paths involve 3 neurons. And I would say that 2 of the 3 are considered interneurons because they're in the spinal cord. So this part right here is the really important part, the crossing over to the opposite side. So they're experiencing the stimulus on this side of the body, but the opposite side of the brain is interpreting it. So I can talk about the spinothalamic tract, and I can say really study this, but there's no questions on the take home. So I just want you to take a breath. And when I say spinothalamic, you can see that this is one example of a specific tract. Now if you go into neurobiology, for example at Xavier, occupational therapy students have to take a neuro class. They will learn every tract. and exactly what it recognizes, where it crosses over, but I don't think you need to know that for nursing. But you can see that the spinothalamic tract is one that identifies pain, which is interesting, tickle, touch, itch. Look at that. There's a specific tract just for those things, those stimuli. So like most tracts, it decussates at the second spinal, and it goes all the way up to the cerebral cortex, third order. So interesting, but you do not have to study that. Again, you don't have to spend a lot of time remembering names of these tracts, but I just wanted to show you three because these are interesting because of the specificity of the tract. Notice this tectospinal is the one that allows us to turn our head when we're surprised by sound. If somebody would slam the door right now, we would all go like this, like what? Who is that? That's tectospinal tract. What? Reticulospinal and vestibulospinal have to do with our inner ear, identifying balance and the special sense of hearing. So those are all kind of interesting. Just remember that there are very numerous tracts, and they all have very specific functions. If there's a disease of the tract, and you can see again a tract that is motor, we call it polio. And this day and age, that I think most of you have never had a polio vaccine. I didn't get a polio vaccine, but I bet you your grandmother and grandfather, watch, if you lift up their shirt, you will see a gigantic scar on their arm. Because that generation still got polio vaccines and left a permanent scar. It must have been a doozy, right? But in third world countries, you can see that polio is still an issue. It's usually caused by contaminated water. And so you can see that if the look at the guy's legs, that if the look at this, that if the motor neurons are not getting any response to the effector, then the muscles just atrophy, they just shrivel up. Kind of like what happens to people who wear, are in a cast for 6 months. That side of their arm or their leg gets way smaller than their other, because they didn't use it.
Can you contract that?
You can contract that from dirty water, contaminated. Usually it's like water where you're bathing in, so it's probably
Like a virus?
It's not going to be something in the United States. Another example, as I talked about, of a disease that deals with the motor component of the pathway is ALS. It says that death within 3 years. And I would say that I only know 2 people that had ALS, and they're both not living anymore. One was the neighbor of my parents. I lived in the same house all my life. And he was a mailman, and he was a great guy. I mean, he was just fit and great, friendly, happy. He got ALS. I saw him at Cervati's Bakery in White Oak Shopping Center, and talked to him. I said, "Oh man, I heard the news." And see, here I am knowing the outcome, knowing what's going to happen. And he said, "Mike, I'm going to fight it. So I'm exercising yet, even more than I ever have. And doctors say I'm really strong." And he only made it a year. It's just a horrible disease. A few years ago, probably 3 or 4, do you remember the Ice Bucket Challenge? Everybody was like sending Facebook videos of, football teams and, 7th grade girls like screaming and getting ice and laughing, and it drove me crazy. It made me mad. My kids did it, and I said, you're laughing. And I said, are you going to donate money to this? Because people who have ALS, it's one of the worst diseases. Because even though their body completely shuts down, their brain doesn't. They are still mentally strong and fit, and everything's fine mentally. Their body just shuts down. So I was always against that ALS Ice Bucket Challenge, and then I think last year they said that they really did raise a lot of money for the Ice
Apparently
Bucket
did a
Challenge.
ton of research.
Yeah, so maybe I was being just bad. So one of the things, and I think Sierra was excited about this, is that on your take-home quiz is an assignment that I think that you will appreciate. when you look at it right now, you're gonna say, oh, you gotta be kidding, Mike. I have to watch a documentary that's an hour and a half? Are you kidding me? I don't have time for that. But it'll be a documentary that, trust me, look at me, that you will never forget. Never forget. And I want you to watch this with somebody that, you know, you would count as someone important to you. Because Steve Gleason was a stud. I mean, look at him. I mean, look at that. I want all that stuff. I want his, look at his hair. And now he can't talk. He can't do anything except communicate with his eyes. You know, and here he was just 2 years ago with his buddy Breeze. I have an intro to it, a trailer to this video. I'll show this. Okay, maybe not. Okay, let's try. You gotta be kidding me. Come on, okay, well, I'm gonna save it for the take home. It's one of the most inspirational stories you'll see, and it's a tearjerker, but it'll be something, and all I want you to do for that part of the question is just write a reflection of how it affected you. So, you know, that'll probably be the most important question that I will enjoy reading. You know, some of those questions are just like, okay, list and explain, describe, draw. That one I'm gonna read. You know, I wanna see how it really touched you. And so maybe you'll think of people with ALS in a different way. He's still alive, by the way. He's lived longer than 3 or 5 years. And he recently it doesn't show this in the documentary, but he and his wife had a second child, which is amazing. Right? Yeah. So obviously they did it outside in a petri dish, but still. Yeah. Yes.
I had, 2 patients that had ALS. And,
How fast did they go?
like in a year, within a year, yeah. It is kind of sad, we did.
No, don't say it's kinda, it's terribly sad.
Yeah, it's very sad.
Yeah.
But my patient who I took care of, she promised us not to tell her children what was going on with her because she didn't want them to worry. But her children.
Did they live far away or something?
No, they were taking her to her doctor's appointment, so they absolutely knew what was going on.
Oh,
Her
okay.
children were like 30 years old.
Oh, okay.
And like when it was getting bad, first she thought she had carpal tunnel, so we were sending her out. That's where she started, like her wrist. Then she wasn't able to use her arms. And then with her breathing.
How old was she?
She was probably like 58.
Oh, that's good to you.
They had a breathing machine. It would force air in her real hard because she couldn't breathe, but she couldn't take that.
Oh.
So one day she told us, like, she was like, I'm ready. So call my children. So we called all her family up there, and she was like, tell them now, Tasha.
How did she communicate?
She still, she had all her.
But she could talk?
Yeah.
Oh, okay.
Yeah, but as she got worse and her voice got real soft, like you could barely hear.
Tasha, I bet, yeah.
So she told us that, which her family already knew, so we called them up. There was a lot of people, and she was like, I'm ready. So she told me, like, tell them now. And I told them, but they already knew, and she said, can you give me an Ativan? And 30 minutes later, she was dead.
So they stopped the breathing machine.
She just went, like, she couldn't take the force, cause it forces, cause she couldn't, her muscle, it's like, she couldn't take it, so it like forces it in, because naturally it'll come back on its own.
Yeah.
But she couldn't take it, so she was just like, I'm ready.
Wow.
She went,
I bet you'll never forget that.
no, I had two patients. It was sad.
That's why you guys are gonna do stuff that I'll never do. You know, I'll never experience anything like that, you know?
Is this related to genetics at all? Like, is it?
Yeah, that's a good question, Ben. I don't know. I'm sure that there's probably something, but
this is weird though, I'm not, you know, I know about ALS and Caucasians, but never an African American. And every African American that had it, that I took care of, was addicted to crack cocaine. Like had a history of crack cocaine addiction. And like cleaned up and got themselves together, and then it popped up.
They
Like
already know the
every,
damage to their body probably.
like every one of my patients, that was
I know
African
several
American,
one.
had a history of drugs.
What'd you say, Ray?
I know several who never were addicted to cocaine.
That were African American?
Yeah. I have one right now, he's 93 years old, he was just diagnosed 3 weeks ago.
Ugh.
He's a Tuskegee Airman. So it has nothing to do with.
No, but the cocaine is a chemical, and you talking about somebody who was,
He's African American, he's never
and he
taken
was
a drug in his
where,
life.
where you say he was?
He's a Tuskegee Airman, you know.
Right, so what was he
They sold
exposed to?
cocaine in little cans. The
Right.
20s, 30s.
Yeah, but I'm
It
saying,
can coke,
Yeah,
that stuff in his
I'm
own.
not saying he did it habitually, but back then,
Right.
like, when you lived back then, you got it, regardless. It was a kid's candy.
I mean, that was just the weird thing about it, like, I'm not saying that if you do cocaine, I'm not saying that, I'm saying like, yeah, it was just the weird that the African American
Yeah.
people that was diagnosed with it, all on their diagnosis had a
Yeah.
history of substance abuse, crack cocaine.
Interesting.
How did someone like Stephen Hawking live to be older than 70?
Well, that's a very good question. That is a great
Is it
question.
just a certain level of resources too?
I think he had a lot of money,
Yeah.
and a lot of, well, of course he did, but, you know, a lot of people helping him.
Yeah.
I mean, Steve Gleason has exceeded his death sentence already, but, you know, he is getting a lot of help. It, you know, it's just something. You know, when we wake up, I always say this, because, you know, we could wake up and say, man, I got stresses of car payments, you know, my relationships with my partner, my spouse, you know, my parents, you know, finances. And yet, you know, Steve Gleason still tweets. So I don't know if you're into Twitter, and I follow, I think, like 25 people. So I'm not a big Twitterer, but I follow Steve Gleason because he'll post things that will tell me some days when I'm just stressed out, like, you know, put it into perspective, Mike. Put it into perspective. Yeah, Mary.
Is this like similar to multiple sclerosis?
No, multiple sclerosis is very gradual, and it usually affects more skeletal muscle, whereas ALS can affect almost every form of motor response. So it's much more devastating.
So, didn't they say so MS, is MS the one that could be related to bacteria?
It can be, and it's also related to a virus, potentially. They're not sure, because multiple sclerosis is really an autoimmune.
Yeah.
It triggers your body to attack the myelin.
I just wonder if they'll find like bacteria or fungi or something like that was
Something
causing
that triggered ALS?
That triggers ALS.
Maybe, I don't know.
It's hard to say. But
Yeah. So here is the blown up version of that dorsal root ganglion, and here's the box up here, so you can see information going towards the spinal cord, and I think you can actually see some cell bodies, some circles with some nuclei. Sometimes the cell bodies are called the soma. Down here you can see the ventral root. So remember the pathway in which it goes. Here's another version of the spinal nerves, and one of the things that we learned in class is that there's a bunch of branches that come off some of these spinal nerves, and we refer to them as a plexus. So we know there's sacral, lumbar, brachial, cervical. So that should be a kind of a quick review from lab. Now with these spinal nerves, we know that in addition to these branches, and you don't have to know this stuff, but the cool thing about these branches is that they continue to subdivide. If you've ever seen like the Body Worlds exhibit and they've dissected out just the nerves, it's the most impressive, overwhelming dissection that I think I've ever seen. I mean, it just looks like almost to the point that they're as thin as like thread, and they're dissected out. So all of that information that goes back to this brain, and here's the part that just gets me. The brain can tell instantly where that came from, where did that stimulus come from, and then send a response back to the exact correct spot. So that's pretty cool. 31 pairs, and they continue to branch, and they continue to branch. So here's an example, and you can see that when we have a branch, you might see a big branch called a ramus, or you might see smaller branches called a plexus, and the whole goal is to get to a final destination. The plexus in our abdominal region is one that we've probably all experienced, maybe playing dodgeball or getting hit by something and you lose your air. You know, I can't breathe, you know, it kind of resets. It takes a while for it to reset and get that diaphragm to be moving again. And so that's the same idea with many of the plexi. One of the issues that's most, I think, concerning to people my age is what happens to these spinal nerves as we get older. And for some reason, some viruses, like the virus that causes chickenpox, can pop back up in the form of shingles. And oh my gosh. So people who are over 50, you might see the sign on Walgreens like shingles vaccine available. Because if you've been exposed to this varicella zoster, which is the virus that causes chickenpox, whether it's through the old-fashioned way of getting it, being exposed to a kid, or even the vaccine, it lies dormant inside of you right now, in all of you. But then something happens where maybe you were exposed to some other virus, and it causes this virus that was once dormant to come back, and it looks exactly like chickenpox. People who have shingles will say, man, I'm getting chickenpox again. I have these red bumps, they itch like crazy, but they don't disappear. They become on fire. And before there was a shingles vaccine, you know, my family doctor would say, you know, that was one of the best medical breakthroughs in his lifetime was the shingles vaccine, because people would literally go insane with shingles, because the bumps became so sensitive that you couldn't even wear clothing on them. If you touched them, it would be on fire. Yeah, Jocelyn.
You can get it before 50. My dad had it when I was young. He was in his 30s and he had it on his back.
Oh, yeah.
So, I mean, he said it was really
Well, you
hard
can
just
get
to
it
wear a
even
shirt.
before
My mom
50.
had it on her
Or
face.
my daughter got it at age 3.
She got shingles, not
She got
chickenpox?
shingles.
What?
So my daughter got the chickenpox shot at age 3, and 2 weeks later she broke out shingles.
Oh no.
And so we took her back to the doctor, and the same doctor that we go to now, and he was like excited. He was like on the phone to the Center for Disease Control saying, oh, I've got a case. I heard him say literally, I've got a case.
How I can't think of the word now, where you can spread it to people. How
Oh,
It's
I
when
don't know.
contagious.
when
That's
their
the word I'm looking
blisters
for.
were
I don't
open.
think that shingles is that contagious.
Okay.
I think that that's something that's pretty much,
Chickenpox.
chickenpox is very contagious.
Right.
Sometimes people back in the day would plan chickenpox parties so that you could get sick in the summer and not during school.
I've never had it. Can I get shingles?
Now, that's a great question. I would say your chances are minimal, but
Should I get a
it's
vaccine?
possible. I mean, are you over 50?
Yeah, you can't get them before 50.
Yeah, you have to wait till 50.
Oh, okay.
All right, so take a look. Here's the cool thing about shingles is that it attacks just one, ready, spinal nerve. One. Remember, there's 31 pairs. It attacks one. And so that spinal nerve, in this case, has a lot of branches, and it shows that it comes only on this side of the back. Notice here's the vertebrae, nothing on this side, nothing on his arm. Look at this woman. The spinal nerve that applies only to this side of her face. Nothing, look, there's a line here. Everything's fine.
Yeah.
It only happens to one spinal nerve. So my daughter had it not here, but on top of her scalp, which was hard to see because she has hair, right? And she was always going like this, dry skin, and it was shingles. So now we know that the shingles vaccine is the way to go. So if you're around 50, your parents are around 50, I've already pursued it, I'm 51. And last time I went, they said, oh, we were out. It's so popular, it's so hard, it's hard to keep in stock.
Should you get it even if you had shingles?
And it requires like going back 2, or I thought maybe it was 3 times. Okay.
So like, should you get it if you've already had shingles? Like, would my dad want to
No,
get it?
yes, definitely get it, because they told my daughter that she's now at a higher incidence for having shingles later in life.
So you can get it more than once.
Yes, 100% yes.
What
Can
makes
be
it
in a
flare
different
up?
area?
What makes it flare up? That is a great question. I think most people think that it's your body's response to another virus. Yes, and then Michael, did you say something?
Can it be in a different area? So like if you.
Oh,
have
yeah. I
here,
mean,
can it be
the shingles can come in different
Big
parts,
ones.
yeah. So it's not always gonna come in this lady's face.
I had it on my back.
You what?
I had it on my back when I was at 13.
Really? Where at?
Just like the middle of my.
Oh, just on one side then, right?
Yeah, I've had them when I was 19. It was right after I had the flu.
Oh, flu virus,
Mhm.
where at?
In my armpit and came down my arm.
Oh God.
Thought it was razor burn, and I was like, look, to my boyfriend. He was like, it's just razor burn. Then it started spreading.
And did it just like become like on fire? Did it hurt you?
It was really painful. Yeah, I remember taking a couple days off work because I used to clean houses, and like I
You
remember
couldn't
laying in
move
bed, like
Yeah.
this, because you didn't want to rub it.
Contact.
Yeah,
Right.
it was painful.
Yeah. Now, in that video that we saw in the beginning of lecture, we saw that a woman was getting a epidural, and epidural probably was in the L1 to L2 range, and there's overlap that probably links to L3 and L4, maybe even L5. So a woman who's getting a pelvic block probably has no feeling in any of their legs, you know? And I'm sure some of you would say, yeah, that happened to me. So what we call the overlaps, we call them dermatomes. And that's another way of explaining why your tongue goes numb during, a cavity getting filled, is that there's overlap. So, and in some cases, the doctors intentionally do that, right? They don't want to have you feel or experience anything. So in class, in lab on Tuesday and tonight in lab, we get to do some reflex testing. One of the things that we get to look at, or I think we did that last Thursday as well, is to talk about the process of identifying the somatic reflex. So on the board, in our big, I'm not going to put it up, but on the board, we have this. We have a chunk of skin. This could have been someone's patellar ligament, right? And we whacked it. Information travels, up, ascending, down, descending, through the ventral root to the effector. And one of the cool things about reflexes, and I want you to write a few of these down, is that the purpose of reflex testing is, one, it helps identify disease and injury. If you think that you have some type of spinal cord trauma or pinched nerve, they're going to do a lot of reflex tests. Skeletal muscle and somatic reflexes can identify development, It's interesting what they do to a newborn baby. I'm talking like in the first 2 weeks of life, what they do to check the development of, look, myelin around these nerves. Because, step out your hand. So sometimes when you're around a new baby, like a fresh one, like under 6 months, you say, oh, baby Stephanie, you're so adorable. Look at her little hand. You know what? Yeah, the baby does this automatically. She grabs your finger and you say, oh, she loves me. She knows that it's Uncle Mike, right? But there's no it's a reflex. And if I put my hand in Steph's hand and she's an adult, she's probably saying, Mike, why are you touching me? Get your hand off. What? This is weird. There's no automatic grab, Same thing with feet. If you stroke the bottom of a baby's foot, the baby's toes go like this, like that. And in you, when you stroke the bottom of your foot, they go like this, oh, like that tickles. Oh, that tickles. So when we look at reflex testing, we can get a lot of information about this pathway. And the coolest thing to me is that reflex tests work when someone's unconscious. So if someone is, in a major car wreck, they're unconscious, you can do all these reflex tests. You can stroke their foot, you can open their eye and shine a light in their eye, and the responses will still work. So that's cool, you know. So somatic reflexes are important. It's a great diagnostic tool. And I promise you that if you ever have any type of nerve damage, pinched nerve, you know, herniated disc, they're gonna do so many reflex tests on you. I'm just telling you. Some of the reflex tests are what we call stretch, and this would refer to the patellar reflex, because when you stretch a ligament or something, it's going to give a very quick response. And I think we're good, right? When we whack the knee, we know, look, and this is like the model that's in lab. Remember, I think there's orange and yellow, and we said, okay, this color is sending information from the set stimulus through the, look, dorsal root ganglion to the track, then look, it says to the brain, and then down through the motor and to the effector, and it would be the quadriceps. And you're gonna have to say quadriceps on the test next week in lab, no doubt about it. So we only did one lousy reflex in lab. Make sure that you know this pathway. In fact, the second question on the modified take home is to draw this reflex pathway. It's called the reflex arc, and talk about exactly what happens to the patellar reflex that we did in class. Okay, so you made it through our first session, and I'm going to say this without getting too sappy, that when I came in on the first day and I felt not the love, but I felt the energy, and I knew that this was an unusual class, and I'm going to say that in my 7 years of teaching here, I've never had a class like this. I would have done anything, listen, I would have done anything to continue teaching you guys in the second semester. Some of you would have said, oh, Mike, we don't want you. But I'm just saying, this has been a special group. I look around and, I say, all of you that are here, and I'm looking around at all of you, you guys are going to be successful. You're going to do whatever you want to do. I know you will. So it was a pleasure, and I really mean it. It was a pleasure. So I'll see you guys in lab. Remember, Tuesday, everybody's here. I mean, upstairs.